Hello, welcome. Good evening, everyone. It's great to see everyone here. Many familiar faces. Welcome to the new faces joining us now at the 5th edition of the Civa Festival. It's our final evening. We had a blast, really interesting conversations, great AV performances, workshops during the past days. Such a wonderful group of international people, and I'm very happy to have this great conversation now. I want to introduce you to Tanja Traxler very first because she also contributed to the catalog and to the exhibition with a text on quantum witchcraft. So this is what we're talking about today. And she also did the brilliant glossary that you can take through the exhibition, and it helps you to understand some of the concepts that we're talking about in quantum physics. And then we have Reinhart and Julia Grillmayr. Also, thank you so much for joining us tonight. And yeah, I give the word to you and wish us a great talk.
Hi, and welcome also from our side. We are very excited to be here, and even more so that you are all here. This session will be on quantum witchcraft. Sounds suspicious. What it all means we will come to in a second. But since we are in a cinema, we will start on a slightly different note.
Yes, Tanja, maybe we should introduce ourselves a little bit before we go into the discussion. Julia, maybe you want to start?
Yeah, hi, also from me. For context, maybe Tanja is also a really great teacher, and I'm gonna just continue with the praise. And she used to teach these really great courses on quantum physics, but without formulas. And that's how I know a little bit about physics. But all I know from physics is from you. So I'm not going to talk about quantum physics per se, but about the feminist science theory that very much also stems from what you wrote about and what we're going to talk about. And my background is, I'm a cultural studies and literature scholar, and my background is in environmental humanities and speculative literature. So there is also a lot of supernatural creatures, and how all this connects, maybe I can contribute a little bit. So that's kind of my role in my introduction.
Well, then I continue because I'm also a non-physicist. I'm Martin Reinhart. I'm teaching at the University of Applied Arts. I'm so happy to see quite a lot of my students here, which I haven't told them at all. I don't know how they got word. I'm here because I also think that Tanja is a great teacher. She's also teaching for our department. She's my, first quantum physicist to go to whenever there's questions. And I'm here because I'm very much interested in the fields that are kind of in the overlapping realms of art and science. That's how our department is also called. And especially I'm interested in the field of magic, and that's a little bit the starting point of our presentation. We will see 2 excerpts from a movie, and this will kind of hopefully get the discussion going.
So finally, just a few words to myself. So I'm Tanja. I was trained as a quantum physicist, and I moved on then to philosophy of physics and more to combining arts and science, in particular quantum physics. I'm based also at the University of Applied Arts, Vienna, like Martin is, and also Julia is somehow. And now into the movie, I would say.
Yeah, so we thought since we are sitting in a cinema, we should start with a cinematic experience. Please, Markus, roll the movie, and we'll talk later. So we will come to Schrödinger's cat a little bit later. But let's talk a little bit about Tesla's cat. Well, we chose to show this excerpt just to get into the mood, but also into the headspace of the 19th century. And if you would have started to study physics around turn of the century, maybe, or a little earlier, people would have thought that physics is basically finished. There's a few remaining questions that needed to be answered, and that's it. So why would you study physics? It's done. But as it turned out, these few questions, and I think that Tanja will go into that a little later, turned out to be fundamental and change everything and question everything. And so physics today is a very different field than it was around that time. And I'm very much interested myself in this kind of relation between magic and science, because it's very interesting to see that magic acts in the turn of the century very often were trying to utilize or even explain new insights in physics. And there was a lot to unpack in this time. So a completely new kind of field was opened with a lot of phenomena that were invisible, namely electromagnetic waves like the X-rays or radio waves, which were very poorly understood. And so I'm saying this because we will come to quantum physics in a minute, but this whole process actually started much earlier. Yeah, it started maybe around 1850, when like the foundations of physics started to shake. And it's very interesting to see historically that at the same time a new kind of religious belief came into being, which is spiritism. It's not something ancient. It was kind of promoted by three sisters, the Fox sisters, which lived near New York, and had their first public appearance in 1849, claiming that they could communicate with the afterworld. And they addressed something unknown, and the world they were communicating with, or claimed to be communicating with, was a vivid world. It wasn't a world of dead people, but it was kind of a parallel universe to ours. And the belief was that these beings, these supernatural beings, on the other side, that we could not see, that we somehow could communicate with, would help us to find solutions to our problems. And I don't want to go too deep into this discussion, but a lot of the scientists that dealt with things like radioactivity or electromagnetic waves actually were spiritists. So, for example, Marie Curie was a member of a spiritistic circle in Paris, and she deeply believed that radioactivity would open the door to another world, and that we could communicate with that world. And I wanted to emphasize that, because when we talk about witchcraft, it's maybe a different concept. It's a different. It's a way to deal with the unknown, and I think that we will kind of circle around this topic while we are speaking. And so that's my little starting point, and maybe I hand over to Tanja at this point.
Yeah. Yeah, as you mentioned, Martin, so in the late 19th century, for example, a young man from Germany called Max Planck, in around 1890, when he was thinking what to do with his life, what to do for a living, he was considering to study physics. And he asked a few people if this sounds like a good idea, and some eminent physicists told him, no, don't do that, that's basically the party's over, that's the job is done. Like classical physics works in a brilliant way, and there are only very few like tiny problems that are left to find a solution for. Better do something else. Planck decided to go into physics anyways, and he tackled one of these seemingly tiny problems, and the way he did so resulted for him to propose that energy is quantized. Sounds like a not so huge idea, but interestingly, from this quantization of energy, a lot of different consequences follow that ultimately led to the development of quantum physics. Planck really didn't like his idea about the quantization of energy, and many other people came along to make contributions to this new field of physics, and some of them also didn't really like what they found. One prominent example is Albert Einstein, who first came up with this idea of what we now call entanglement. So a very interesting connection between two or even more particles that has no counterpart in classical physics. And in a way to express his disliking of entanglement, Einstein came up with the phrase spooky action at a distance. And I find this curious. So the natural sciences in the modern area have a very long-standing reputation as ghostbusters. It was a very strong promise and force of the natural sciences to explain away supernatural entities, ghosts, whatever, with rational explanations. That's an extremely powerful and successful project, obviously. And given that, I think it's extremely interesting that when you look back in the history of science, again and again there are these moments in science when scientists encounter phenomena that do not make a sense within their scientific framework, scientific worldview. And in these moments, very often, supernatural entities are being introduced back into the canon of science. Laplace's demon is one example. Maxwell's demon is another example. And especially quantum physics is teeming with ghosts to address blank spots where at some point the rational failed and people were hoping for better explanations than the ones they have in hand. With this empty dots, so like Leerstellen, or spots of emptiness. Maybe Julia, you want to catch up here.
Yes, sure. So I thought this idea was really interesting to think about this as a kind of empty space, maybe, where something is happening, but we don't know exactly what. And so all of a sudden a supernatural entity, a ghost, a demon, whatever comes out. So as I said before, my background is in speculative literature. So there's such entities anyway, but it's very interesting that often in either science fiction or in fantasy, these entities are here, but as you said before, this ghost-busting idea is also the case for when you consider the genre science fiction, and most people have an understanding of it as maybe something called like hard science fiction or like science-based, whatever. And then you, Rudi Rucker, who is also a physicist and a mathematician and a science fiction writer, he told me once, or he wrote somewhere, that writing science fiction is piling up the miracles but keeping a straight face, as maybe in contrast to like fantasy, where you don't keep a straight face because you just put out the miracles there. So from this background, with all these supernatural entities coming back, but then kind of are not really a metaphor, I would say. I mean, maybe they're also a metaphor, but not merely. They're also like a very powerful stand-in for the not yet known, but very often also where it's already suggested maybe this is not knowable at all. so they make their appearance there. So I was wondering, with all also, I mean, I was asking myself, with all the, when you look at a bookstore today, there are so many ghosts, there are so many demons, there are so many also other entities like dragons. So fantasy and science fiction have made this huge comeback in popular culture since like 20 years or so. So I was just wondering how these figures maybe relate to fictions also. Is this, would you say, something more like this stand-in, which comes from a like very primary idea of, okay, this is so it's not knowable, it's invisible, so it's a ghost? Or does this relate also to maybe, I don't know, in the case of like these theories that come from different times, but do they relate to maybe also like what was popular as like fictional entities? Is there a relationship between that?
I would definitely say so, yeah. I mean, I think it's also not a coincidence that now with quantum physics, the ghosts are very popular, while previously demons were much more prevalent. And this is definitely also very much intertwined with the cultural and political times at which, in which these personas are being introduced into the scientific canon, and it's a way, or it's an attempt to make sense, and in a sphere where you are lacking words. I mean, very often in science you are lacking words anyways, because formulas are so much more powerful to describe precisely what is going on, that language anyways so often might lead you astray. But the translation to language is extremely important when you try to make sense, when you really try to push the frontiers of knowledge. That's very hard only within like the existing technological terminology alone, I believe. And I would argue, so we had this epoch of demons in physics. We had also plenty of ghosts already around in quantum physics, and now it's the age of the witches.
That's what would be my follow-up question, like what personas now? But maybe if I can just say something to the language part, because what your text also for the catalog that I was able to read already, and it's very interesting and very good. So where you describe these moments, as you just said, where these supernatural figures appear, and you describe them as kind of, there is some empty space. And what resonated with my research or my field that I'm interested in, which is more like maybe ecology more than physics, it's also often a language problem, because if you're interested in, let's say, more than human ecologies, then very often these worlds are approached with words, and then there is some, in the translation, something doesn't work. And maybe this has also something to do with the unknowable, in the sense of, we have here like the feminist theory maybe coming in, where you have feminist and also other like critical emancipatory epistemology, where you say, okay, but maybe this idea of, okay, we can know everything and just shed light in every corner and then it's known. Many people have thought this is very uninspiring when you encounter a more than human world that you consider is very complex, but not in the sense of, oh, this is very complex data, I have to analyze it and like cut it in little pieces and then I will be fully understanding what's going on, but rather this idea of really being immersed maybe in a space, or having communication maybe, but that always has a part where language doesn't quite fit, like human language doesn't quite get it. So I think these feminist epistemologies also, where they're like more intersectional ecofeminist concepts of talking about nature-culture divide or tackling the nature-culture divide, they are also full of these moments of, as you said, like these spots where there is some emptiness, and this emptiness is not something negative, where you say, oh, we have to fill it or get rid of it, but this is an emptiness that we could maybe consider more as a space that keeps us moving, because now there's a little bit more freedom to move. Yeah.
I don't know if what I'm going to say now is I hope it's supporting your argument, but we have to understand also that like at least Western culture in the 18th century has kind of been expelled from paradise. I mean, the Newtonian physics basically presented an idea of the world, of the universe, that was totally logical, without any flaws, and Newton was a man of the Bible. He believed that this was God's creation, and everything that we would not understand or that would not be explainable was because we weren't not smart enough to understand God's works. And at least for 200 years it has been that way, and there was actually no contradiction between there being a God and being that natural world that we could perceive and understand. And I think that this order that existed until maybe the French Revolution or a little bit after that, kind of also was interpreted as dramatic or even traumatic, because suddenly a whole system of belief and explanation just vanished, and it created a big uncertainty. And I think in order to fill like these gaps, it needed different ways of explanation, and the supernatural, or as we can see today, this kind of emptiness that we have to explore needs a certain how do you say a courage. It needs a rigor to put the first foot into the empty space, and I think that science fiction is a very kind of important tool actually to explore the unknown and to make a first step. And so we have learned to live with the idea that's a little unsettling, that there is no guidance anymore, and we have to explore this world by ourselves. And there is no guarantee that we will find a useful solution, or that we will find understanding at all.
I have a question to you both, actually, and I'm aware that it's a bit ironic because I have the tarot shirt on, but I think we're up here and in our fields of research and into critical feminist science theory because we love science very much and scientific attitudes. I don't say this specifically about witchcraft, but without this whole aestheticization of like more the esoteric realm, how does this relate to, let's say, embracing the demons, the ghosts, the quantum witches, which I'm totally up to, but how does these fields relate, like, or these, yeah.
I think it's a very important question, and to me the best answer is one of actually our favorite books, namely How the Hippies Saved Physics by David Kaiser. I don't know how many of you know about it, but it's a very interesting historical study how in the 1970s the counterculture movement and the hippie movement merged for a specific historic moment with the development of quantum physics. So it was a very odd attempt, for example, to use the concept of quantum entanglement to explain telepathy, also the whole like bullshit concerning quantum healing or quantum esoteric or you name it, can be traced back in a way to that period. The core group members in this endeavor, they didn't produce anything substantial scientifically. However, they made a very important contribution to create a field from which new developments emerged. In the end, it doesn't matter where good ideas come from, but it matters how they are being like picked up and what follows from this. And when you look back in the development of quantum physics, it had a very dire middle age in the 1950s, 60s, where not really much was going on. And somehow, in retrospect, it seems that this contact with counterculture movement, with hippie movement, with totally non-scientific contributions were necessary to make the next big step forward. It was only through the contributions of this group that, for example, Bell's theorem was being picked up. It was neglected before that for a long time, and people actually found the courage to go into their labs and try to test it and realize it.
Yeah, taking LSD sometimes helps.
It definitely does. Now read the book and you will know why.
We're losing our audience now.
Coming back to what you were saying earlier, Martin, I think it's really fascinating in the times that we are living right now, also concerning science. So you described this long epoch where Newton's physics was the paradigm and it was like a safe haven. And now, since more than 100 years, we have both quantum physics and general relativity as the two big theories in physics. And what is extremely interesting to keep in mind is that quantum physics, or also relativity theory, didn't do away with Newtonian physics. So there's a very interesting parallel existence between all these historical contributions. And even though we know today that there are some extreme cases where relativity theory is the much better like description or quantum theory, still there are so many real world problems where Newtonian mechanics is just the most useful strategy. So it's a very interesting parallel existence, I think.
Maybe one word to that. I think I refer to the 19th century, the effects of these findings in physics were already used while they were not understood. So Marconi, for example, he broadcasted like Morse signals around the world with electromagnetic wave, and there was not even a theory how it could work. Or Röntgen named the X-rays X-rays because the X stood for I have no fucking idea how it works. And same is true for today. I mean, we use quantum effects for different purposes, but we don't have the big image. So we can say, okay, it works, it's there, but still, what is it? We don't know.
Is this the witch part, like the cauldron that you sometimes taste, but you don't know really what's happening until...
Yeah, maybe.
So actually my question was like, the witch, is it maybe also the figure that is doing something which is productive, and something comes out from the cauldron and sometimes it works, but the witch doesn't pretend to know beforehand everything that is going on, maybe. So maybe it's a different attitude to what also our description, the scientific description of the world is.
Yeah, for me that's a very good example why the witch could be productive. So I think supernatural beings, or the introduction of scientific fiction, or in physics it's often called Gedankenexperiment, like Schrödinger's cat. To do a Gedankenexperiment to create a fiction within science can be productive. It can also lead to nothing, but it at times, or to very wrong conceptions, but at times it can also be productive, as the history of science shows. And why witches can be productive for the current stage of quantum physics, for me also resonates with feminist theory. There have been many different examples and contributions that highlighted in which senses the philosophical consequences of quantum physics are so much more compatible with feminist theory than with traditional Western male philosophy or Aristotelian philosophy, for example. I think for the big foundational questions we still face in physics today, another philosophical take is necessary. And this would be for me another reason why witches maybe now could be productive.
I would even go a step further. I was at a conference 2 weeks ago, and it was very interesting because there was a group of young scientists that went to Kazakhstan in order to research ancient myths and beliefs that people shared there, and stories they told each other. And they found out about a place in this region they were researching, and there was a mountain that was taboo. So they said it's a sacred mountain, you should not go there, it's leave the ghosts alone, and so on and so on and so on. And what they found out was that this was a very highly radiant uranium kind of source, and there was a knowledge about that you just should not deal with this radiation. And they had no scientific explanation for that, but very well they knew that things were kind of dangerous or they should avoid to be there. And maybe one could say that we should kind of revisit our knowledge. And when I say knowledge, I don't mean academic knowledge or scientific knowledge, because the fact is actually really dramatic. I mean, we basically only know 3% of energy and matter in the universe, which means we don't know about the 97% that really make the universe. And if you only have a probe of 3%, what can you say about the whole thing? And we had a discussion lately. We are talking about dark energy and dark matter just because it's not dark because it's dark. It's dark because we have no clue whatsoever. And so how do we handle that? And physics is, if you want to, in a really dramatic phase right now. What can you talk about if you don't have 97% of matter and energy there?
Yeah, the difference to Max Planck times is striking, where people thought we basically know everything, so don't bother to go into physics. And now we know that we don't even, that we for sure know not much about 95% of the universe. What Martin said reminded me of atom-semiotic, or where you have
there's a whole research field that you know about. It's like nuclear semiotics, which goes a bit the other way around. Like they want to instrumentalize this kind of, it's not implicit knowledge, but like cultural knowledge, transcendent knowledge by your ancestors. They told you already there are ghosts, don't go there. And nuclear semiotics has one job, which is to figure out how to put science and what kind of science on nuclear waste grounds. So we know this will be not toxic, but harmful to the environment and human and non-human bodies for much longer than our natural language actually is like stable like that. So we are sure these signs will not be in like US American English, stop here, it's toxic. So exactly. So it's a bit it's a thought experiment also, and it's often compared to something like SETI, like Search for Extraterrestrials, because you don't know how to communicate. And it's almost, if you go like deep time into the future, it's almost the same problem. Like what language can we put on these signs? And often more like cultural knowledge. There was one very prominent proposition was to have like a kind of a priesthood. It's like all kinds of, where we know from history that knowledge is transmitted very reliably. So priesthood, cultural beliefs, religious beliefs, maybe even, So that's, and of course, who did the nuclear semiotics people ask? They asked science fiction writers to join them to imagine these scenarios. And I was also thinking about that when you mentioned this. Yeah. Maybe for the dark matter, what I found really interesting that what comes becomes visible here, and also in the way I'm talking right now, is that we much rely on eyesight, which has been often said like in like that science in this like modern Western science idea very much is like oculocentric. The feminist theorists say in a critical way, like maybe we can also have other kinds of knowledges that are not relying on our eyes so much. And the dark matter for me is also such an example. Like we have to shed light. It's like enlightenment. It's all these ideas, and this also comes up very often in like environmental humanities or in the field I'm in. I'm very much interested in wetlands and the very strange reputation they have. And there is also this idea of muddiness, of being opaque, of not being able to divide properly, of not seeing anything. This is always the problem. This is why the swamp gets treacherous in fiction very often. So I think it's not only physics, but all kinds of science fields that have this uncanny moments when the eyesight is in trouble or is troubled or something.
I guess you like black holes, don't you? I guess you like black holes.
Yeah, exactly, black hole, yeah.
And how did you investigate the swamps, if not with eyesight?
Well, I was in an artistic research project that relied very much on sound. And, you know, the field recording practices are very, very developed also in like people who are interested in the modern human landscapes, but very often you go for like the perfect field recording, no humans, but we were interested in sites that are contaminated in this way, so that if you do a field recording, you actually can hear how much like this nature culture divide doesn't make any sense. But in the coming back to like more ecofeminist theory, we write it without the nature culture, like not hyphenated, but in one word. I think this goes back to Donna Haraway, where you can really not. She would actually like to mix maybe the letters, but nobody would understand. But the idea is really to merge these two together, so that you cannot say, okay, I'm doing a field recording of nature. And if you do this in the places where we go, which has been mostly Lobau, for example, and so I was part of the collective called Lobau Listening Comprehension. You have a field recording and it's like, oh wow, this is so nice. But then if you don't rely on the eyesight, but you listen, oh, there is a dog, which is kind of an anthropogenic thing. Or there's like children speaking, there's the motorway always you can hear, oh, there's a train coming from the oil harbor. So you have all these, it's still a wetland, and we can still cherish it for like the, let's say, wilderness it kind of transmits, or we can feel there. But relying more on our ears than our eyes, this also very harmful idea of like puristic nature culture things, it doesn't work anymore, for example. Yeah.
I think the big elephant in the room is emptiness. And also for emptiness, you have the problem that seeing is not a very useful strategy to get more insights. Because for seeing, I mean, you need at least one photon in order to see something, and that's already more than true emptiness would allow. What's your take on emptiness?
I think I'm really sorry about what I'm going to say. It's probably a bit boring, but I'm a trained comparative literature scholar, how do you say, recovering literature scholar. So I grew really up with like post-structural literary theory, and there you always have this idea, or there's this gap, and then like the signifier and the significant, you know about that, yeah. And there's always this gap, and then there is like representation that is kind of covering the object behind. And you cannot come to the object because there's always representation. There's always the word and not the thing itself or whatever. And then you have this idea of there is this emptiness, and so always signs come up. And there are all these signs, and you're never in the world, in the real world. And I thought the theories to turn it around, and this is maybe true for Gilles Deleuze, with whom sometimes we have, or for me, it's a bit, it's been a while since I've thought about Deleuze, but together we thought a bit about Deleuze as well. I thought these theories were much more interesting, where you don't think this as an emptiness, but rather as a too much. And I think for ecology, it's the same thing. You don't go somewhere and say, you don't know anything, and so this is emptiness, but it's rather a too much comes out of this gap between word and world. And this is actually also the beauty of it somehow. So I think in this case, emptiness is not such a good go-to, rather the surplus of, also maybe experience is really interested in this.
But you were basically talking about noise. And it's our friend Philipp Haslinger, who's also a quantum physicist, and I think you were students together. I don't know if he's in the room, and if he's in the room, please correct me if I say something wrong. But as far as I understand his research, they work with electron microscopes, and he told me that, you know, for the last 40 years, we have tried to get rid of the noise and to get very clear images of this atomar and subatomar world, which we can only see via these instruments. And since it's so evident that we have missed something, because otherwise we would kind of see this energy and this matter that we don't know about, they started now to look at the noise. They took the oldest microscopes they could find at the university, which were the worst ones in our belief, and now they start to look at the noise and see if they can find a signal. And I find this very interesting in terms also what you said, that this kind of concentrating on the image or the beautiful image or the clear image maybe makes us blind. Maybe we don't see what we're looking for. And I was very interested in what you said lately about the gravitational waves, maybe you can, which is maybe an equivalent to hearing more. So maybe you could kind of elaborate a little bit on that.
Yeah, since we mentioned black holes also earlier, and for black holes we have the very same problem, since they are black, so once light or other electromagnetic waves come close enough, there is no escaping. So electromagnetic waves are not a very useful tool to investigate black holes. You can get some information, but not the crucial things you want to know. And therefore, I follow with great interest in this development of gravitational wave astronomy, which is a totally different class of signal. So we have learned so much about the universe with different types of electromagnetic waves of different frequencies. But there are some entities out there, and black holes are definitely among them, but probably also dark matter and dark energy. It's very hard to find something useful with electromagnetic waves, but black holes and the detection of gravitational waves that come from black holes could be a new angle to address that. Yes, you're right, so gravitational waves have metaphorically often been translated to hearing the universe, while electromagnetic wave astronomy more invites for the metaphor of seeing the universe. For me, what is so interesting about emptiness and the quantum approach to emptiness is also that it calls for an in-between something and nothing. So in quantum field theory, the quantum vacuum is not entirely empty. That's not possible for different reasons, but it's also not necessarily teeming with matter, but something in between, so going beyond this dichotomies of something or nothing. That also has, of course, to do with the uncertainties, the irreducible uncertainties that we are very often confronted with in quantum physics. And for me, this is one of the most relevant questions at this moment. What about the emptiness? There is obviously so much more out there, as we know, with dark matter and dark energy. To us, this seems like empty space. We don't see anything, and we also don't get other signals, but it's definitely not empty, though it seems like it.
What a great way to end a panel. But how much time do we still have? 15 minutes.
You have a question?
No. It was just the time
Does anyone have a question? Yeah.
I have a question.
Yeah.
So far, or this one, even better.
Thank you. So far, it seems like many of the physicists that you referred to having thoughts coming from witchcraft or coming from so-called non-scientific notions tended to be in basic research. I guess my question would be, does this also crop up in applied physics or like in applied research? Because like currently, this is oftentimes one of the things that slows down humanity's progress is when there's not as many applied solutions. So like right now, there's a huge wave of funding leaving quantum research because there's been such a slowdown in quantum computing progress. And what that's, usually has longer term effects for basic research as well. So my question would be, do ideas around witchcraft and the paranormal also come up in applied research? And if not, how would one promote witchcraft and applied research?
Yeah, very good question. I mean, my take on this would be that it's really, really hard to differentiate so neatly between basic research and applied research. It always goes in circles, and obviously one promotes the other and vice versa. New ideas in basic research are essential to be in the position to make technological progress, etc. But then again, technological progress is so essential to make new discoveries that bring forward research in basic science. Gedankenexperimente have always been much closer in theoretical research than in experimental physics, for example. But very often it were these Gedankenexperimente or fictions that then had a big influence on how experiments were conducted and what kind of experiments were conducted. I think you also have a great story to that.
We just talked earlier about this, and when 2001 by Stanley Kubrick was released, there was one NASA official, and he said, until now, everyone has been stealing our ideas from the promotional films NASA made about the lunar missions and so on. And now it's time that we steal from visionaries like Kubrick. And I thought this is an interesting turn that once. I think it's always a game, that science leaps forward, and then human fantasy catches up and even overtakes, and this is where the whole game turns around. And this would maybe be my answer. I mean, witchcraft is really meant very metaphorical, but I think that we need this kind of pushing the limits forwards, and it in the end it doesn't matter who is pushing the limits. If it's a science fiction author, if it's an esoteric, if it's a West Coast drug addict or whoever, or a scientist, it does not matter. In the end, we need that kind of momentum. And I think at the moment quantum physics is so popular because it fuels so many ideas and so many fantasies, and even in blockbuster movies there's kind of Ant-Man is entering the quantum realm, and it's just everywhere, and of course there's a lot of nonsense, and every physicist would say, okay, that's not possible or that's not even thinkable, but let's try. Let's. It's kind of it's and I find this wonderful. I find this is so lively and so human to just figure things out. And some of them fail, or most of them fail. But among a million ideas, maybe there's one that really helps us to make the next step.
Maybe I mentioned Rudi Rucker in my first answer, maybe in my last as well, because he wrote some fictions. There is one short story on the net that you can read for free. It's called Apricot Lane. Because I'm so spoiled here. Normally I'm always like on like more fiction panels, and people are like, yeah, thank you for your research. What should I read? Give me your reading recommendations. So I'm doing it automatically now. But he wrote some fictions, among them Apricot Lane, that I enjoy. Especially where there's quantum telepathy. He's also a bit in this kind of how the hippie saved physics generation, and he's definitely also like this Californian guy. So let's just say, and there is quantum telepathy, and everybody's like kind of contaminated by quantum telepathy. It is like sexually transmitted as well. It's a really great story, and it has also the effect that you kind of can communicate with everything. Like everything, you realize everything is sentient, and so even this glass and this tree and this leaf, like everything, and. Because first you said also Madame Curie or Marie Curie, was thinking about opening a portal to a new world, and maybe it has like radioactivity. For Rudi Rucker, definitely, I would say quantum physics is this, like in his fictions, this is not really, it's still science fiction in the sense that, of course, it's completely fantastical, but for him, it's like another description of the world, actually, as he also, as a mathematician, could understand, for example, something like entanglement. Like there's a lot of things going on here with all these particles, and why not call this sentient? So this is like kind of his idea. And I don't know really about this, but like about the math he does, but it makes for a great science fiction story in any case.
I think we have time for one final question. Now we have two, so we have to.
Thanks for the conversation. I have one comment, or let's say food for thought. So I really dislike this portrayal of quantum mechanics as murky or swampy, actually, because it's the most precise theory that physics or humanity really ever came up with, right? We can describe precisely things that reach like from nuclei, single photons to neutron stars. So it's incredibly precise. I think the real striking thing of quantum mechanics is that despite its precision, right, despite its clarity, we have no pictures, right? We have no images. Maybe we also shall not make ourselves images. But the even cooler thing, I think, of quantum is that it actually can even put very precise formalism on these emptinesses, right? So there are these classes of theories that are called no-go theorems. So where people, very smart people, came up with, oh, maybe there are, let's say, some explanations for the weirdness of quantum. And they could show actually that they don't exist, right? So we can really precisely say what we cannot say, in a sense, right? So this is, I think, something, you know, with all murkiness and cauldronness, you know, we shouldn't get carried away. Like, there are precise bounds to what we can say about the nature, and we should also keep that in mind when we theorize and philosophize about these things. Thanks.
Yeah, very important. Thanks.
I would have one question, like regarding witchcraft as a method, as you said, to maybe explore more those emptiness and noises. I wanted to ask you what you would say, like, we can maybe observe and also then adapt to modern scientific teaching from the persona of, like, the witch, like which activities or attitudes can we, like, adapt into the modern teaching?
That's really a tough one, and definitely one that will stay with us for longer than this panel. But I mean, in general, I think, also referring to your comment, given that there is such a powerful mathematical apparatus that works, so there is not so much to do concerning the mathematical work in quantum physics. It works extremely well, extremely precisely, but where still so much work to be done is in the conceptual work, because many of the concepts that we use are very vaguely defined, have a very leaky philosophical foundation, and this is a huge contrast to the mathematical apparatus of the theory, and there is where I see real work to be done. So going really into this conception and considering very closely the words that we use to try to make sense what is going on. Do you want to add anything? I think we are at the end of the panel. Thank you very much for your interest. We will be around for questions, of course, and thank you.
Yeah, thank you so much for this wonderful talk. We'll have a little break for setting up the live AV performances by the Instrument Inventors Initiative Collective coming up.